Okay, today we're going to talk about rational expressions and equations, and it's very important that you know how to factor by this point. Okay, and we've been factoring using slide and divide, so that's what I'm going to be doing here when we get to factoring. Okay, multiplying and dividing rational expressions. Finding the domain of a rational expression. It's important to find the domain because we're going to have to find what's called restrictions. The restrictions are where the asymptotes go. It's where the domain jumps at, where there's an error on the domain. We need to know that because in the denominator, you're never allowed to have 0. So if we put that number in, we're going to get an error because, or undefined, because 0 can never be in the denominator. So it's very important that we find out where the domain is restricted at. To find out where the domain is restricted at, and I told you this previously, the domain is always negative infinity and infinity unless you have a square root or a root that's even, or you have a denominator that has a variable in. And we do have a denominator with a variable in, so what you do is you take that denominator, x plus 3, and you set it equal to 0, because we don't want it to equal 0. We solve, and x is negative 3. That means x is negative 3 cannot happen, because the domain would be negative infinity to negative 3, jump negative 3 to infinity, because there would be an asymptote there, which is an imaginary line that the graph gets close to but never touches because it's a legal boundary point. Okay? So we're going to take this denominator, we're going to set it equal to 0. I'm using the square root property. I'm bringing the 4 over, and I square root both sides, and p is equal to plus or minus 2. But I could have used my factoring and did p squared minus 4 equals 0, p plus 2 equals 0, p minus 2 equals 0. So p equals negative 2, p equals positive 2. Therefore, x cannot be plus or minus 2. Meaning, if I was doing this as a domain, we would start at negative infinity, we'd run to negative 2, we'd jump negative 2, we'd run to positive 2, we'd jump positive 2, and we'd go to infinity. Big split domain. I needed to make x squared minus 5x minus 14 equals 0. So I broke it into x minus 7 and x plus 2. X minus 7 equals 0, so x can't be 7. X plus 2 equals 0, so x cannot be negative 2. Therefore, it cannot be these. So if I was writing the domain, it would be negative infinity to negative 2, jump negative 2 to 7, jump 7 to infinity. Now we're going to use these two ways. One, we're going to use it to find our domains, and two, we're going to use it to find our restrictions. Restrictions, you only have to put x cannot be 7 or negative 2. You do not have to put the whole domain portion out. But on the domain, you will have to put it all out as the function notation. Okay, so we're going to start by simplifying. To simplify a rational expression, the first thing you have to do is factor. So I took x squared plus 2x minus 15, and I broke it into 1 and 15, 3 and 5. 5 minus 3 makes 2, so I put plus 5 minus 3. Then on this one, I slid over and got x squared minus 9x plus 18. 1 and 18, 2 and 9, 3 and 6. I want to add for negative 9. So I did x minus 3, x minus 6, divided by 2. Slide and divide, so I got the 2x minus 3 and the x minus 3. Okay, once I have it broken down, I can cancel any part of the numerator with the denominator as long as it's not connected in a way that I can't do that. So I can. This is my answer. But I have a restriction. X cannot be 3/2 and x cannot be 3. Don't forget your restrictions. So my answer is x plus 5 and 2x minus 3 as long as x is not 3/2 or 3. Okay, so get over here and I have to factor. This is a cubic. So a is q, b is 2. So a minus b, a squared, plus a times b, plus b squared. On the bottom, I can pull out a 3q. So q minus 2. So 3q and q minus 2. always do my restrictions. I try to do my restrictions first. So 3q cannot equal 0, so q cannot equal 0. And q minus 2 cannot equal 0, so q cannot equal 2. Here are my restrictions. Now, q minus 2 is on the top and q minus 2 is on the bottom. So I get q squared plus 2q plus 4 over 3q. This is my answer as long as those two things don't occur. Slide x squared plus 11x minus 12. 1 and 12 we'll subtract for 11. So x minus plus 12, x minus 1. Divide by the 3 that I slid. So I have x plus 4, 3x minus 1. This does not simplify over 1 minus 3x. Restriction, 1 minus 3x cannot equal 0. Subtract my 1. Divide by my negative 3. X cannot equal 1/3. There's my restriction. Now remember from our factoring unit, if we have total opposites, I can pull out a negative 1 and switch the terms and their signs. So this will drop out. I'll get negative 1 times x plus 4 or negative x minus 4 with these restrictions. Now, when we multiply, we do exactly the same thing. We factor the numerators and the denominators, we just have more factoring to do. So x plus 5, x minus 2. And x can pull out, so x plus 7. X plus 7, x minus 3. So I'm going to do my restrictions first. This cannot equal 0, so x cannot equal negative 1. This cannot equal 0, so x cannot equal negative 7. And this cannot equal 0, so x cannot equal 3. And if you need to do them by setting them up, that's fine. Now remember, I can cancel any numerator with any denominator. So I have an x plus 7 here and an x plus 7 here, numerator, denominator. And that's the whole gist of everything. I cannot cancel this x with this x because this is attached to 1. So I'm left with x times x plus 5, x minus 2, over x plus 1, x minus 3, with the restrictions that are listed there. Sometimes a lot of things cancel out, sometimes not. Okay, difference of squares. I'm going to put it down here. P plus 3, P minus 3. P plus 6. Oh, nope. 6's are always hard because 6 and 1 make 5 and 2 and 3 make 5, but I'm adding for 5, so it's plus 2 plus 3. Times, this becomes P squared minus P minus 6, which is P minus 3, P plus 2 divided by 3. So P minus 1 and 3P plus 2. Over, pull out your 2, P minus 3. Restrictions. This one, P cannot be negative 2. This one, negative 3. This one is not a restriction because 2 will never equal 0. And this restriction is 3. Okay, I have a P plus 3 on the top and a P plus 3 on the bottom. It doesn't matter if they're in the same fraction or not, just as long as one's on the top and one's on the bottom. I have a P minus 3 on the top and I have a P minus 3 on the bottom. It doesn't matter if they're in different fractions as long as I'm multiplying. So I'm left with P minus 1 times 3P plus 2 on the top and a P plus 2 on the bottom with these restrictions. Oh, and I have a 2 on the bottom. Almost forgot that. It's always good to look back over. Okay, y plus 1, y plus 1. Slide y squared plus y minus 6, y plus 3, y minus 2, divide by 3, y plus 1, 3y minus 2. Y plus 4, y plus 1. Okay, I have a y plus 1. Oh, let me do my restrictions first. Y cannot equal negative 1. 2/3, -4, and -1. Okay. I have a y plus 1 on the top and a y plus 1 on the bottom. I have a y plus 1 on the top and the bottom. Okay, this is 2 minus 3y, and this is 3y minus 2. So if I put a -1 here, I can switch this around, and I can cross those two off. So I'm left with -1 over y plus 4 with these restrictions. Now when we go to divide, the rules are the same, except just like when you divide fractions, you have to change this to multiplication and flip the top and the bottom of only the back fraction. We're now going to factor like we would factor any other time. X plus 2, x minus 2. Pull out a 3x, x plus 3. Pull out an x, x plus 5. Slide x squared plus 7x plus 12. X plus 3, x plus 4. Divide by 2. So it's 2x plus 3, x plus 2. I like to scribble it out so I don't get myself confused, or do it in a totally different spot. So 3x can't equal 0, so x cannot be 3. Oh, 0, I mean. If 3x can't equal 0, you divide by 3, x can't be 0. X plus 3 can't equal 0, so x cannot be -3. 2x plus 3 can't equal 0, so x cannot be -3/2. And x plus 2 can't equal 0, so x cannot equal -2. Okay, I have a plus 2, plus 2. I have an x and an x, and I can cancel them because there's no addition or subtraction sign in here, so they're not put together that I have to hold them. So I'm left with an x minus 2, an x plus 5, over a 3 times a 2x plus 3 and an x plus 3. Okay. So division is like multiplication, you just have to flip the back one. Okay, this is just a double stack fraction. If I unstack it, it becomes 20x to the x to the fifth, 3y, divided by 4x squared over 15y squared. So these are going to switch. Because there are no addition or subtraction signs in any of them, I can cancel one thing at a time. So 20 goes into 4, 20 and 4 reduce to 5, x to the fifth and x squared reduced to x to the third, 3 and 15 reduced to 5, y and y squared reduced to y. Now you cannot cancel these two 5's because they're both on the top. So I get 25x cubed y. Restrictions. X cannot equal 0 because 4x squared cannot equal 0. And y cannot equal 0 because 3y cannot equal 0. Okay, this is just a double stack too. X squared minus 4x minus 12 over 4x cubed minus 6x squared. If you don't mind, I'm going to flip it as I go. So 2x cubed minus 4x squared plus 8x over x cubed plus 8. Let's factor. X minus 6, x plus 2. Pull out a 2x squared, and I'll have 2x minus 3. Pull out a 2x, and I have x squared minus 2x plus 4. 4 breaks into 1 and 4, 2 and 2. Add for -2. Doesn't work, so I can't break that down anymore. This is a cubic. So a is x, b is 2. So x plus 2, because it's a plus b, times a squared minus ab plus b squared. Now, 2x squared cannot equal 0, so x cannot equal 0. 2x minus 3 cannot equal 0, so x cannot be 3/2. X plus 2 cannot equal 0 is a negative 2, and this does not break down, which means if I did do it, it's going to become go into a quadratic or be imaginary number, so we don't need a restriction on that. So I have an x minus 6 on the top and no x minus 6's on the bottom. I have an x plus 2 on the top and an x plus 2 on the bottom. I have a 2 on the top and a 2 on the bottom, and I have an x on the top and an x squared on the bottom, leaving me an x on the bottom. I have an x squared minus 2x plus 4 on the top, and I have an x squared minus 2x plus 4 on the bottom. Left with x minus 6 over x times 2x minus 3 with these restrictions. Now, I want to remind you about adding and subtracting. Adding and subtracting gets harder because in adding and subtracting, you need to have a common denominator. So for us to do 1 over 6 minus 5/8, we'd have to find a common denominator between 6 and 8, which is 24. To go from 6 to 24 multiplied by 4, so I had to multiply the top by 4. To go 8 to 24, I had to multiply by 3, I had to multiply the top by 3. So 4 minus 15 is negative 11 over 24. Nothing changes just because we put variables in. We still need a common denominator. We still need to reduce at the end. Okay, so these first two have a common denominator, x plus 3, so I don't have to change the numerator. So x plus 3 stays on the bottom. So I have an x squared plus x squared, so it's x squared, and I have a negative 3x plus a 7x, which is 4x, and I have a 6 minus 3, which is positive 3. Now I have to do 1 and 3. Break into x plus 3, x plus 1 over x plus 3. Restriction, x cannot be negative 3. The plus 3's cancel out, so my answer is x plus 1 with this restriction. Reducing means I factor and simplify. On the next one, they look kind of like the same denominator, but if I would put a negative 1 here, I could switch this to x minus 2. It doesn't matter which one I put the negative 1 with. So now I have a denominator of x minus 2 on both of them. I get 3x minus 1. I can't reduce it, but x cannot be 2. What if they're not binomials and they're monomials? Well, look at them. 8 and 12 both go into 24, and x squared and x both go into x squared. So this picks up a 3, and this picks up a 2 to get to 24 and an x. So I get 9 plus 2x. Cannot be reduced, but 24x squared cannot equal 0, so x cannot be 0. These two, I say what's in common, and people will tell me, oh, x is in common. No, remember, if there's a plus or minus sign, it's all or nothing. They're either x plus 3, both of them, or x plus 2 for both of them, or they're all nothing. So these have nothing in common. Anytime you have nothing in common, you have to use both of them. So this had an x plus 3. It's picking up an x plus 2, so I have to multiply the top by x plus 2. This had an x plus 2. It's picking up an x plus 3, so I have to multiply the top by x plus 3. This needs FOILed. So I get x squared plus 2x minus x minus 2 plus x squared plus 3x. So I have 2x squared, 2x minus x is 1x, plus 3x is 4x, minus 2 over x plus 3, x plus 2. Well, my restrictions are x cannot be negative 3 or negative 2. Slide. 1 and 4, 2 and 2, subtract for 4. Nope. Okay, how about pull out a 2? X squared plus 2x minus 1 over x plus 3, x plus 2. Still not going to reduce. So it's one of these two answers with those restrictions. Okay, got to factor the denominator before I can tell if they have anything in common or don't. So I factored it. What do they have in common? Well, they have an x plus 4 in common. That means I don't have to write x plus 4 twice. I can just write it once. What don't they have in common? Well, they don't have an x minus 2 and an x minus 4 in common. So this one had the x plus 4 and the x minus 2. It didn't have the x minus 4. And this one had the x plus 4 and the x minus 4, and it didn't have the x minus 2. So I'm going to have to FOIL. So x squared minus 4x minus 1x plus 4 plus, FOIL again, x squared minus 2x minus 1x plus 2. Let's see, 2x squared, negative 4, negative 5, negative 6, negative 7, negative 8x plus 6, all over x plus 4, x minus 2, x minus 4. I can pull out a 2. X squared minus 4x plus 3. 1 and 3 add for negative 4. So 2 times x minus 1, x minus 3. Okay, so I took this, took out a 2, then I factored it here. So I'm right now left with 2 times x minus 1, x minus 3 over x plus 4, x minus 2, x minus 4. X cannot be negative 4, 2, or 4. I can't cross anything out, so there's my answer. So I factored it to see if I could reduce it, and then it didn't reduce anyway. So that's why you need to know how to factor well. Okay, let's factor. X plus 3, x minus 3. Doesn't factor, doesn't factor. So common. 2 of them have an x plus 3. 2 of them have an x minus 3. There's nothing left that somebody has that no one else has. So this picks up nothing, so it stays as a 6, or it picks up a 1, whichever way you want to think of it. This picks up an x minus 3, and this picks up an x plus 3. But I'm going to warn you right now. Anytime you see a subtraction, if you do not change the sign, change the sign, change the sign, when you go to FOIL, you're going to blow those signs, and when you blow those signs, you're going to get the problem wrong. So always change it first. 6, FOIL, plus x squared minus 3x plus 1x minus 3. FOIL, minus x squared minus 3x plus 2x plus 6. Because I had to change it to an addition and change the sign, change the sign. My x squares drop out. I have a negative 3x and a 1x, which is negative 2x, which drops the positive 2x out. So I'm left with a negative 3x. And I have 6 minus 3, which is 3, and 3 plus 3 is 9, over x plus 3, x minus 3. I can pull out a negative 3 and get x minus 3 over x plus 3, x minus 3. So x cannot be negative 3 or positive 3. The negative 3's cancel out. The x minus 3's cancel out. I'm left with negative 3 over x plus 3. So that's my answer with my restrictions. So you ask yourself, how much more complicated can it get? Well, we're going to do adding, subtracting, multiplying, and dividing all at one time. But do not freak out. I gave you a 3-step way of doing it. 1, simplify the numerator. So 3 over 1 minus 1 over x. Change the sign, change the sign. Step 1, find a common denominator, x. This gets an x, this gets nothing. So I get 3x minus 1. Step 1 is finished. Step 2, combine the denominator. 1 over 1 plus 1 over x. Common denominator, x. This picks up an x, this picks up nothing or 1, so I have x plus 1. Step 3, take step 1, which is the numerator, and divide it by the denominator, which means I'm going to flip it and multiply. So x cannot be 0, x cannot be negative 1. Cancel x and x, top and bottom. So 3x minus 1 over x plus 1 with these restrictions. Now the only time this is going to change is if parentheses were added into the operation and it made you do the numerator and denominator first and then do the operation. That normally doesn't happen. Okay, so step 1, numerator. Common denominator 3x because they have nothing in common. Multiplied by x, multiplied by 3. X plus 3. Step 1. Step 2, do the denominator. Find a common. Done. I love when they're already done. Step 3, take step 1 and divide it by step 2, which means I'm flipping it. Restrictions. X cannot be 0 or negative 3. The x plus 3's cancel out, so I have 2 over 3x with those restrictions. Use the 3-step process. It makes it so much less complicated. Step 1, 2x over x plus 4 minus x minus 7 over x squared minus 16. First thing I'm going to do is change it to addition and change the sign, This is x plus 4, x minus 4. Common denominator, x plus 4. They have a common, x minus 4 they don't. So this is picking up an x minus 4 because it didn't have it previously. So I have 2x squared minus 8x minus x plus 7. 2x squared minus 9x plus 7 over x plus 4, x minus 4. That was all step 1. Step 2, x over 1 minus x squared plus 4 over x plus 4. Change the sign, change the sign, change the sign. This is going to pick up an x plus 4 because the common denominator is x plus 4. So I get an x squared plus 4x minus x squared minus 4. So I get a 4x minus 4 over x plus 4. There's step 2. Yeah, I'm kind of using the whole page here, aren't I? So 2x squared minus 9x plus 7 over x plus 4, x minus 4, divided by, flip it over, x plus 4 over 4x minus 4. Okay, let's factor. This becomes x squared minus 9x plus 14. 1 and 14, 2 and 7. X minus 7, x minus 2, divided by 2, divided by 2. So I have 2x minus 7 and x minus 1. 2x minus 7, x minus 1. This one I can pull out a 4 and get x minus 1. Restrictions. X cannot be negative 4. 4, this is not a restriction because 4 will never equal 0, and 1. Let's start canceling. 2x minus 7 on the top, none on the bottom. X minus 1 on the top, x minus 1 on the bottom, x plus 4 on the top, x plus 4 on the bottom. So I'm left with 2x minus 7 on the top and a 4 times x minus 4 on the bottom with these restrictions. I know it's a lot of work, but if you take it step by step, it doesn't seem as if it's too cumbersome, okay, and you're not sinking. Okay, so what happens if I add an equal sign? Well, actually, when I add an equal sign, it kind of makes my life easier. I still have to find a common denominator if I'm adding or subtracting, but I can put the common denominator out front. The common denominator of 2, 3, and 6 is 6, and the common denominator of x, nothing is x. So now that it's out front, x goes into 6x, it picks up a 6. 6 goes into 6, picks up an x. 2x goes into 6x, picks up a 3. 3 goes into 6x, picks up a 2x. Once I did that, the denominator's gone. So I don't have to deal with it anymore. So 2 times 6 is 12, minus x equals 15 minus 2x. Bring my 2x over, bring my 12 over. X is 3. Now I did need to do my restrictions, but I didn't. This was 0. This was not a restriction. This was 0. That was a restriction. X is not 0, so this is an answer. Now, if it said x couldn't be 3 and I got x is 3, then I'd have to cross x plus 3 out and say no solution, unless another one was there too. P minus 3, P minus 1, P minus 3, P plus 1, P plus 1, P minus 1. Common denominator. 2 of them have a P minus 3, 2 have a P minus 1, and 2 have a P plus 1. Nothing else left. So this one had the minus and the minus, so this gets the plus. This had the minus 3 and the plus 1, so it has a minus 1 that it picks up. And the other one had the plus 1, minus 1, has a P minus 3 that it picks up. So I'm going to come up here. 3P plus 3 plus 6P minus 6 equals 5P minus 15. So I have 9P minus 3 equals 5P minus 15. 3's going this way. 5P's going that way. 4P equals negative 12. Divide by 4. P is negative 3. Now let's see what my restrictions were. P could not be 3. P could not be 1. And P could not be negative 1. My P was negative 3. Therefore, it's all good. Already broken down. 2 of them at W minus 1, and 1 has a W. So I'm going to have to use W and W minus 1. This first one picks up a W. This second one picks up a W minus 1, and the third one picks up a W. So I get W squared plus 3W plus FOIL, W squared, minus W plus 5W minus 5 equals 3W squared plus W. Denominator drops out, but W cannot be 1, 0. Okay, what I got? 2W squared, 8 minus 1, 7W minus 5 equals 3W squared plus W. Everything has to come to one side. I actually might take it the other way because I don't like negatives in my leading coefficients when I factor. So I'm going to bring my W squared this way, my 7W this way, and my 5 this way. That way I get W squared minus 6W plus 5 equals 0. W minus 5, W minus 1. W equals 5, W equals 1. Now look, I have a restriction that W cannot equal 1, so I have to cross it off. So the only answer that will work is W equals 5. If W equals 1 is the only answer there, then it would be no solution. Put a 1 and a 1, common denominator, 1x or x. This picks up an x, this picks up a 1, this picks up an x. So x squared plus 4 equals 5x. Since I have an x squared, everything has to go to one side. So I can factor 1 and 4, subtract negative 4 and negative 1 equals 0. X equals 4, x equals 1. Restriction right here. X cannot be 0. Neither of them are 0, so they both work. Now, what if we have literal equations and we need to solve for them and we have variables in the denominator? Well, we do the same thing. We're going to find a common denominator of f, p, and q, which is f, p, and q. F picks up a pq because it has the f. This picks up an fq. This picks up an fp. So I have pq equals fq plus fp. Now from there, I'm going to do my different solvings. So I'm going to need this 3 times because they solve differently each time. Okay, the first one wants to solve for f. Both the f's are on the same side, so I pull them out. I divide by q plus p. So f is equal to pq over q plus p. The next one I want to solve for p, so I need to get the p's on the same side. PQ minus FP equals FQ. Pull out the p. Q minus F equals FQ. Divide with Q minus F. P is equal to FQ over Q minus F. Hey, we're practicing literal equations too. Okay, the next one, we need to solve for Q. So I have to get all the Q's to one side. So PQ minus FQ equals FP. Pull out the Q. P minus F equals FP. Divide by P minus F. Gone. Q is equal to FP over P minus F. So we use what we're doing here by finding a common denominator, losing it, then solving for each letter. Okay, what if we have similar triangles? Well, the first thing I do is I always find one side from each triangle that I know for a fact. And I know that 22 goes with 14. So 22 goes with 14 as 30 plus x goes to 30. I also know that 22 goes to 14 as y minus 15, or is that y plus 15? Plus 15 goes to y. So I cross multiply and I get 660 equals 14 times 30, 420, plus 14x. Subtract my 420. 240 equals 14x. Divide by 14. 240 divided by 14 gives me x is approximately 17.14, and that would be units. 22y, cross multiply, is equal to 14y plus 15 times 14, 210. Subtract my 14y. 8y equals 210. Divide by 8. Y is equal to 26.25 units. So that's how you handle similar triangles. Now, I didn't have to do proportions. I could have came out here and did 14 times 30 is 420 and lost a fraction that way. Would still got the same answer, or I could have used 240 because they both go into 240. I could have came out front here and did a 14y. Okay, so we could have 210. Let's try that. 210 divided by 14. Yeah, these both go into 210, so I could have done 210 as well. One or the other would have to happen. I did the proportion rather than losing the fraction because I saw it as a proportion in my mind's eye. I think it's easier to do it as a proportion if it's set up that way, but really what you're doing is losing the fraction. Okay, let's talk about work problems again. Kevin can cut the grass in 3 hours and Peter can cut the grass in 2 hours. How long would it take the two of them to cut the grass together? Well, Kevin can do 1/3 of the job and Peter can do 1/2 of the job because it takes him 3 hours, so he can do 1/3 of the job in 1 hour. Together, I have no idea how long they take, but we have one job to do. Common denominator is 6. So this picks up a 2, this picks up a 3, this picks up a 6. So 2x plus 3x equals 6. 5x equals 6. Divide by 5, x is 1.2 hours. So it's going to take them 1.2 hours together. And that makes sense because Peter can do it in 2 hours. If they work together, it has to be less than 2. A sink can fill in 5 minutes and drain in 8 minutes. If the drain is left partially open, how long will it take to fill the sink? Well, a sink can fill in 5 minutes, so it can do 1/5 of the job in a minute. We are draining, so they're working against each other, in 8 minutes, so it can do 1/8 of the job in a minute. We don't know the time together, but we're doing one job. Common denominator is 40. So this is picking up an 8, this is picking up a 5, this is picking up a 40. 8x minus 5x equals 40. 3x equals 40. Divide by 3. X is 13 1/3 minutes. In 13 1/3 minutes, we're going to have an overflowing sink, even if the drain's left open. Okay, these two are working together, so we added. These two are working against each other, so we subtracted. But they were all the part they can do in one portion of the time for a total job times the time it takes them together. Kevin can cut the grass in 6 hours, and together with Peter, he can cut the grass in 4 hours. How long would it take Peter to cut the grass alone? Well, Kevin can cut the grass in 6 hours, and together with Peter, he can do it in 4 hours for one job. But we don't know what Peter's rate is, but we know together they do 4 hours. So the x this time is Peter's rate. So I have 4 over 6 plus 4 over x equals 1. I can reduce if I want, but I'm just going to put the 6x out front. This picks up an x, this picks up a 6, this picks up a 6x. So I have 4x plus 24 equals 6x. I'm going to move my 4x over. I get 24 equals 2x. Divide by 2, x is 12 hours. Therefore, it takes Peter 12 hours to cut the grass. A plane flies 990 miles into the wind and back 990 miles with the wind. The wind is 20 miles per hour. The round trip takes 10 hours. What is the speed of the plane? So we have two planes. Together they take 10 hours. So we're doing our time, d over t. So we have 990, and we're flying into the wind, so that's speed minus the 20 wind. And we have 990, and we're flying with the wind, which is speed plus 20. Common denominator, s minus 20 and s plus 20. This picks up an s plus 20. This picks up an s minus 20. This picks up an s plus 20 and an s minus 20. So 990s plus 19,800 plus 990s minus 19,800 equals, I like to FOIL this first and then multiply by 10, so I get s squared minus 400 times 10 is 10s squared minus 4,000. So these two cancel out. This becomes 1990 plus 1990 is 1,980. And I'm going to move that 1,980 to this side. So 10s squared minus 1980s minus 4,000 equals 0. Pull out a 10. S squared minus 1980 s minus 400 equals 0. Factor. 1 in 400, 2 in 200. Oh, bingo. So 10 times s minus 200, s plus 2 equals 0. 10 equals 0. Nope. S minus 200 equals 0. So s is 200. S plus 2 equals 0. So s is negative 2. Well, I don't think a plane can go negative 2, so that's out. So the speed of my plane must be 200 miles per hour. Now remember, we had to find which one of these were. We used d over r equals t, and then we found a common denominator, lost the denominator, solved it by factoring. Your turn to practice.